Okay, so we're going to talk about geometric sequences. We are not going to talk about geometric series. To talk about geometric series, we have to talk about infinite geometric series and how they either converge or diverge. And that's just not something that's necessary right now. As I said in a previous video, that is something that we do cover in Algebra 3, but not in this class. So a geometric sequence is a sequence in which the ratio between any two terms is constant. So notice we went from a common difference to a common ratio. Just kind of be aware of that, and we'll talk about what that ratio is in just a minute. Again, remember in the videos, you can pause where you need to finish copying, things like that. Common ratio is the numerical ratio between any two terms, and the variable that we use is a lowercase r. So for arithmetic or arithmetic, it is a common difference, which means that we are adding or subtracting a number. In geometric, it is a common ratio, and we are either multiplying by a number or dividing. And when we divide, we can't say if we're multiplying by 4 that our ratio is 4, and if we're dividing by 4 our ratio is 4. So when you're dividing, it's 1 over that number. So like if you notice that it's going down by like dividing by 4, then you would say 1/4. Okay. Now you can have a ratio that's not 1 over a number. You can have a 2/3 ratio. That's kind of what a ratio is, right? A number over a number. But just know that if you write division, so again, if you notice it's dividing by 2, we don't write just 2, we write that we're multiplying by 1/2. So common ratio is multiplying. Sort of like common difference is adding. We're just either adding a positive or we're adding a negative. Okay? So determine whether the sequence is geometric. If yes, identify the common ratio and give the next 3 terms. So number 1, we go from 6 to 12 to 24 to 48. Clearly geometric, we are multiplying by 2. And the next 3 terms would be 48 by 2, which is 96. 96 by 2, which is 192. And 192 by 2, which is 384. Number 2, so we have 810 to 270 to 90 to 30. So you may have to try it in your calculator to see what's happening. When you do this, it's always the second term divided by the first. So 270 divided by 810 gives me a ratio of 1/3, which is divided by 3. Then it becomes a little clearer. 270 divided by 3 is 90. 90 divided by 3 is 30. So it is geometric, and that common ratio is 1 over 3. So we're multiplying by 1/3. Then 30 divided by 3 is 10. 10 divided by 3 is 10 divided by 3. And then divide by 3 again, or multiply by 1/3, gives me 10 over 9. Okay, number 3. So definitely can see that I'm multiplying by 5. 2 times 5 is 10. 10 times 5 is 50, and so on and so forth. However, notice that the signs are swapping, and that should give you an indication about something about your common ratio. and that should be that your common ratio is negative. The only thing that can make the sign flip-flop is if the ratio is negative. So you could have a complete series like a number 7 or sequence that's all negative, just like you can have an all positive and your ratio would be positive. But if it's flip-flopping, so the sign is changing, then you know your common ratio has to be negative. So if my common ratio is negative 5, then 250 times negative 5 is negative 1250, then 6250, and then negative 31,250. 31,250. Okay. Number 4. So there's no common ratio. So it's not geometric. So 4 times 2 is 8. And then if I was going to keep that pattern, then the next number should be 16. And it's not. So it's obviously not a pattern. Okay, number 5. So again, I see that sign is flip-flopping, so I know my common ratio is negative. I also know that I am dividing or multiplying by a fraction. 4 divided by 4 is 1. 1 divided by 4 is 1/4. 1/4 multiplied by 1/4 or divided by 4 is 1/16. So my ratio is negative 1/4. And my next 3 terms, so multiply by negative 1/4. So the next one's going to be a positive, 1/64. Next one has to be negative, 1/256. And the next one will be positive, 1/1024. So number 6 is a little deceiving because the pattern, there is a pattern, a pretty obvious pattern. 2 squared is 4, 4 squared is 16, 16 squared is 256, which is a nice pattern, but it's not geometric because I'm not multiplying by the same number over and over again. So it's not geometric. So number 7, notice they're all negative, so my ratio is absolutely not negative if it is geometric. I don't have a sign flip-flopping. So obviously 2 to get to 14 is 7. So then you might have to check if 14 times 7 is 98, and it is, and then 98 times 7 is 686. So my common ratio is a positive 7, not negative because my sign is not flipping. And my next numbers are rather large. So times 7 is 4802, times 7, 33,614. And then times 7, 235, 298. Number 8. So when you throw that decimal in there, it can be a little confusing, but you can always revert back to what I said. Take the second term, 8 divided by the first, which is 3.2. So 8 divided by 3.2. And that gives you 2.5. Now, if you're not sure, you might want to check the next one. So 8 times 2.5, 20, 20 times 2.5, 50. So it does complete the pattern. Don't just rely on the first one. So this is yes, and my common ratio is 2.5. So then 50 times 2.5 is 125. 125 times 2.5 is 312.5. And then 312.5 times 2.5, 781.25. So just like the arithmetic sequence, the geometric has a formula. So the nth term, and it is explicit, which means that if I want the 10th term, then I plug in 10. the nth term of any geometric sequence can be found using the formula a sub n is equal to the first term, a sub r, times the common ratio to the n minus 1, where a sub 1 is, like I said, the first term, and r is the common ratio. Now notice we have an exponent. It's the easiest way to tell the difference in a geometric and an arithmetic is the exponent. If it has an exponent, then it's geometric, the formula. If it doesn't, then it's likely arithmetic. That's what you would see the difference on ACT. These did appear on the Algebra 1 test, have for several years. I'm not really sure why, but it's usually just like one question. But that is the way you tell the difference. So I think that you could imagine with an exponent how quickly geometric sequences can get out of control, meaning very, very large numbers very, very fast. So when you start talking about the 10th term, you're raising something to the power of 9 and then multiplying it by whatever the first term is. So these numbers can get very, very large or very, very small quite quickly. So just kind of bear that in mind. So don't freak out if you get a 6 or even a 9-digit number. It's likely to happen, okay? So it says to write a rule and then find a sub 6. So remember, writing the rule is part of your problem. This will be the same thing on the quiz, and this will be the same thing on the test. You'll have to write a rule. So that's part of the problem. Write the rule. So it should have an R in it. An N in it. And then you'll find whatever the selected term is, okay? So number 9, so our rule is a sub n is equal to a sub 1 times r to the n minus 1. Okay, so I need my a sub 1. Well, that's easy enough. It's given it's 1. And then I need to know what my common ratio is. So what is my common ratio? I'm obviously multiplying by 5. So my rule is a sub n is equal to 1 times 5 to the n minus 1. Now, the only time this will ever simplify is if it's 1. Remember, you cannot multiply before you do exponents. That's just basic order of operations. But because it's 1, we can say that our rule is 5 to the n minus 1. Okay? Remember, you cannot multiply before evaluating exponents. PEMDAS, parentheses, exponents, then multiplication and division from left to right. So there's my rule. And then if I want to find a sub 6, that means 5 to the 6 minus 1. So a sub 6 is equal to 5 to the 5th. So the 6th term in the sequence is 3,125. Okay, so same thing for number 10. My first term obviously is given 130, and you need to figure out the common ratio. Again, if it's not blaringly obvious to you, which I would not be surprised if it wasn't given that it's decimals, do the second term, so 65 divided by 130, and you get a ratio of 1/2 or 0.5. So my rule would be a sub n is equal to 130 times 1/2 to the n minus 1. And that's my rule. And if I want to find the 6th term, that would be 130 times 1/2 to the 6 minus 1. So 130 times 1/2 to the 5th. So my 6th term, so make sure you do your decimal first. Your exponent first, so 0.5 to the 5th is 0.03125. And then we're going to multiply that by 130. And we get 4.0625. And we can leave that as a decimal since the originals are in decimal form, the original sequence they gave us. So number 11, again, the first term, 2. I need to find the common ratio. I'm obviously multiplying by a -4. I know it's negative. Notice the sign flip-flops. So it's -4. So a sub n is equal to the first term times the common ratio to the n minus 1. So that is my rule. And then if I want to find the sixth term, that would be 2 times negative 4 to the 5th. So a sub 6, so negative 4 to the 5th times 2 would be negative 2048. Now, if this happened to have been an even number, if they wanted you to find the 7th term, make sure you put that negative 4 in parentheses. If not, it's still going to yield a negative. So make sure you type it in the calculator just like you see it with parentheses, okay? Number 12, my first term is 8. My common ratio, 3. I'm multiplying by 3. So a sub n is equal to the first term times the common ratio to the n minus 1. So my sixth term would be 8 times 3 to the 5th. So the sixth term, so again 3 to the 5th times 8, 1944. Very good. Number 13, again, A1, 135. Common ratio, again, maybe not super obvious, so take the second term divided by the first. 90 divided by 135, get a decimal, so I'm going to change it to a fraction. It's a repeating decimal, so I don't want to round it or I'm not going to get the right answer. So I'm going to change that to a fraction, and I get that my ratio is 2 over 3. Again, 90, the second term divided by the first, gave me 0.666667, which I cannot round or I'm not going to get the right answer, so I changed it to a fraction. So remember, that's the second PRB, enter, second ABC, enter, and it will change it to 2/3 for you, which the second PRB should work since it's not a improper. So then my rule, a sub n is equal to my first term times my common ratio to the n minus 1. There's my rule. So my sixth term, 135, times 2/3 to the 5th. So a sub 6. So make sure you put your 2/3 in parentheses. 2/3 to the 5th times 135. So because that's a repeating decimal, I'm going to change it to a fraction. It's not a terminating decimal, so I'm going to change it to a fraction because I don't really want to round. So we'll do 160 divided by 9. Again, that would be the second PRB, enter, second ABC, enter. Number 14. So my first term, negative 3200. And I need to know my common ratio. Again, it's obviously something negative because I'm flip-flopping. My answers are getting smaller, so I know I'm multiplying by some fraction. So I can do 800 divided by negative 3200, and it gives me that my ratio is negative 1/4. So again, a sub n is equal to my first term times my ratio to the n minus 1, and that is my rule. And then to find the sixth term, I plug in to the 5th. So again, parentheses are extremely important. So parentheses, negative 1 divided by 4 raised to the 5th times negative 3200 is 3.125. So again, terminating decimal, I'm going to leave it as a decimal. Non-terminating decimal, I'm going to rewrite as a fraction because I don't want you to round. You don't have to round for this one because it's a terminating decimal. So number 15, so this gives us different pieces of information. It doesn't give us the sequence. It just gives us information about the sequence. So this is perfect because a sub n is equal to the first term times the ratio to the n minus 1. So I have my rule. And to find the 8th term, then I do 7 times 4 to the 8 minus 1. So 7 times 4 to the 7th. So my 8th term, 4 to the 7th times 7. Pretty big number. They do get bigger. 114,688. So number 16, it's the same formula. A sub n is equal to a sub 1 times the ratio to the n minus 1. The only difference is we're not given a sub 1. They want us to find a sub 1. So they give us an a sub n. So my n is 5. And this is the number that I plug in for a sub n. So a sub n is negative 68 times is equal to a sub 1 times my common ratio is negative 0.5. My n, if I'm using this number, is 5 minus 1. So negative 68, a sub 1 to the negative 0.5 to the 4th. So I have negative 68 is equal to a sub 1. So I need to know what negative 0.5 to the 4th is 0.0625. So then, of course, to solve for a sub 1, I divide. So I have negative 68 is divided by 0.0625. And I get that a sub 1 is negative 1088. Okay. Number 17, so we're given a sub 1, a sub 4, and want us to find a sub 3. But the problem, if you look at the formula, is I don't have r, so I can't find a sub 3 without r, so I need to use these two pieces of information to find r. So my a sub n would be 4459. Remember, a sub n is the value, the term value. N is the term number. A sub 1 is 13 times my ratio 4 minus 1. So I'm going to divide by 13. So 4459 divided by 13 is 343 equals r to the 3rd, 4 minus 1. To get rid of a cube, we cube root it, right? So 343 cube root is 7. So my common ratio is 7. Now I can very easily find a sub 3. So a sub 3, it didn't tell me I had to write the rule, just said find a sub 3. So a sub 3 is equal to the first term, 13, times my ratio, 7 to the n minus 1. So I have 7 squared times 13 is 637. Okay, we are not going to worry about 18. We're not going to work any like that. You'll be given a sub 1. You could have to find the ratio. You could have to go back to like number 16 and find a sub 1, but I'm not going to give you this information without giving you a sub 1. Okay? Or the ratio, one or the other. Okay, so on page 7, I want you to do numbers 1 through 16 and then 19 and 20. You are going to turn this in today. The sub has these instructions. If it's not in the basket today, you will not receive credit. Okay? Your quiz tomorrow. Don't forget, you'll do that when you first walk in, and then you'll have time to finish this tomorrow after your quiz. Okay? If you need the time to finish it.